In DSS-G we have different plots. Those plots normally depend on a single element, which is the energy meter. Some other plots can be generated with monitors. The energy meter is a special element that normally is placed at the feeder head and, well, at the head of different zones depending on what you want to do. But it's special because it allows to register several variables and quantities that are critical for or are related to the model operation. In this case, with the energy meter we have at the feeder head of this model, we're going to do a yearly simulation. And to go faster, we're going to activate the temporal parallelization included in the parallel processing suite in OpenDSS, so we can go faster. We're going to run the simulation. We can see in this case I have 6 threads running, and we're done. So the first plot I want to present here is the voltage profile. The voltage profile in DSS-G, if you have OpenDSS viewer installed, has 2 parts. One is the 3-dimensional voltage profile, which is the same as in 2 dimensions. It's just each one of the faces is separate on a 3-dimensional space. And the second one is the traditional flat bidimensional voltage profile. We can export the data provided by OpenDSS into an Excel spreadsheet, so we can play around with the quantities that we got from the simulation. Another interesting plot is the scatter plot. In the scatter plot, we can see the voltage profile in terms of the GIS coordinates for the system, which is very nice. Actually, we can render those 3-dimensional graphs to see them better. And we can see here, for example, the voltage profile that is also scaled in terms of colors, but each one of the voltage values are placed on according to the GIS coordinates of the model. And we have some other tools that is worth to explore. We have some other plots when you have enabled the demand interval functionalities of the energy meter. In this case, what we're seeing is the kWh during the year for the feeder. So we can check the demand in terms of month and the hour of the day. So we can see what are the peaks of demand and etc. The behavior of the demand across the year. We can do the same with the reactive power. Also with the losses, we can evaluate losses in terms of kV or kWh. Also, we can see the peak values and etc. So right now we're going to see losses in terms of kWh. Again, these 3-dimensional graphs can be rendered so we can see it better. Could be to print it, to export it, to make a copy, etc. And also we have all the functionalities of the 3-dimensional graphs, like zoom in, zoom out, everything combining the mouse click with the control key and shift key. We have also other graphs that are can give you a lot of information, like for example the branch to node matrix graph, in which we can see the connections in between branch and nodes across the feeder. So by selecting the cursor in this graph, you will see at the bottom of the window the name of the branch and the bus to which it is connected. You just move the cursor to the point of interest, and that will bring the information. We can do the same with the Laplacian matrix. In OpenDSS-G, we have all the reports provided by OpenDSS, so you can have access to those using the reports menu at the menu bar, are basically the same that we have in OpenDSS. And we have exactly the same at the tools palette. So we can generate very quick voltage report, current reports, powers, etc. Also, the reports can be generated from the OpenDSS console. For example, by sending an OpenDSS command and execute, I can trigger those reports very easily. Also, there's another alternative called quick measurements. Quick measurements is a graphical way for defining a region of interest and getting all the measurements, the instantaneous measurements for that region, highlighting the elements that where I'm making the measurement. I can get voltages, currents, powers, losses, and I can apply some filters to have information only about loads, lines, transformers, etc. So let's go here and let's create, let's define a wider, a bigger region of interest. As you can see here, every time I click on the name of the element that where I'm making the measurement, the element will be highlighted on the schematic. And I'm going to bring all the different values. Also, I can look for the element, locate the element within the GUI, filter elements, bring all the other variables that I want to measure, and everything with just a click.